So, gang, we are going to review elasticity of demand, and somebody, I'm not even sure is here, asked if we could go over some of the quiz questions. So what I'm going to do is look at some of the quiz questions, change the numbers a little bit, but kind of go over the same kinds of questions. That way you can go back and take a look at the quiz, maybe practice again. If you use what we learned today, go back and practice the quiz questions, then I think you'll be in great shape. So, let's start with the simplest kind of question. So the simplest kind of question is where I just give you the data and ask you to calculate elasticity of demand. So let's suppose we increase the price of our product. You're going to want to write down the questions because it doesn't make sense if you don't write down the questions. We increase the price of our product from $8 to $9, and as a result, sales fall from 100 to 85. What is the elasticity of demand? So, easiest type of question. Now, guys, I would urge you, whenever you start a question, automatically start by writing down the equation. I think if you write down the equation, it kind of grounds you. It will help you frame the problem appropriately. So, elasticity of demand. We know it's going to be the percent change in quantity demanded over percent change in price. So we have to figure out, given the information that I've got, price changes from 8 to 9, sales fall from 100 to 85. What do we have to do? So remember, to calculate anything that is a percent change, we need that, what I called, and this is purely made up, that new equation, right? And remember why I call it new. New minus old over old, right? New minus old over old multiplied by 100%. And some of you might be making mistakes because you forget the 100%, or you cancel it when you can't really cancel it, and that might be causing part of your problems. So, everyone get out their calculator. I'm going to do the numerator with you, but then you're going to finish this problem. So guys, what is our new quantity?
85.
85, good. And our old quantity is?
100.
100, good. Divided by our old quantity of 100, multiplied by 100%. And I would urge you not to just start dropping your 100%. Write it out, then cancel it if you're sure it can be canceled. But let's not get sloppy and kind of cut steps, because sometimes that's where we make our errors. So, everyone can do the denominator. Everyone write out the denominator really quickly. And then we'll clean it up. So write the denominator. And did you get 9 minus 8 over 8 multiplied by 100%? Mm-hmm. Everyone agree? All right. So from here, I can cancel the 100%. Can somebody explain to me, why can I cancel here? Mathematically, what is the principle here that's telling me that I can cancel this?
Is it percent?
It's the same.
Because I have it on the same and the bottom. So understand that when it's on the top and the bottom, do you agree it's basically like a form of 1, right? It's like 5 over 5 or 10 over 10 or 20 over 20. Same kind of idea, right? So now I can clean it up. But do you understand, can I just drop it from the top if I don't have it on the bottom? No, and so you got to be really careful there. And that's where people make a lot of stupid mistakes. Okay, so let's continue with our problem. Everyone agree, if I clean this up, I get negative 15 over 100 divided by 1 over 8. Everyone agree that I should have a negative number somewhere, right?
Yes.
Because if P goes up, quantity goes down. If P goes down, quantity goes up, right? So I have that inverse relationship, so it's really important that you remember. All right, so let's take our calculator, and I want you to calculate a decimal for the numerator and a decimal for the denominator. Okay? Calculate a decimal on the top and a decimal on the bottom. So did you get 0.15 on the top? Yeah? And then what's 1 divided by 8? 0.125. Good. 0.125. All right, but I got to be careful. I dropped my negative sign. I'm being careless. So put my negative sign back in. So now 0.15 divided by 0.125 equals, everyone agree, negative 1.2. So if I take the absolute value of this, then I get what? 1.2. Easy. Okay. So for this example, consumers have elasticity demand of 1.2. Let's remind ourselves, what does that tell us? Are our consumers elastic or inelastic?
Elastic.
Okay, so we have an elasticity demand that's greater than 1, and that tells us that they are elastic, right?
So it's elastic because it's between
Greater than 1.
after 1.
Exactly.
Okay.
That's all there is to it. So remember, let's go over that again. If your elasticity is greater than 1, we call that elastic demand. If your elasticity is exactly equal to 1, that's a special case, and it's unitary elastic. And if our elasticity demand is less than 1, it is inelastic. So that's just memorization, okay? You with me? Okay. So make sure you remember that part. Now, I want us to take this 1.2 and make sure that we understand what that really tells us. So let's work one backwards, okay? All right, everyone with me? So let's say, let's make example 2. A study reports that the elasticity demand for good X is 1.2. Your firm is considering a price increase of 8%. How will quantity demanded, in other words, your sales, be impacted? So a study reports that elasticity demand for good X is 1.2, and your firm, which makes X, is considering a price increase of 8%. How will your sales, your quantity demanded, be impacted? So, again, as I've always suggested, you start with the equation. So elasticity demand equals percent change in quantity over percent change in price. And let's plug in what we know. All right. So, can I plug in for elasticity of demand?
Yes.
What can I plug in?
1.2.
1.2.
It'll be negative 1.
Ah, negative 1.2. That was my next question. Why is it negative 1.2?
Because it always is.
Because it's always a negative number. And so one thing you need to remember, let's write a big note to ourselves. Remember that elasticity of demand is a negative number.
And you always take the absolute.
So when we work backwards, we have to put it back in. Put the negative sign back in. That's crucial. If not, you get the absolute wrong number, and you will get the wrong answer on a test. Okay? So we have to put in the negative sign. Do not forget. All right, what else can we plug in here to this equation?
The price
Okay, price has done what?
increase.
Increased by 8%. All right, so I need to leave that percent sign in there. Okay, so I've got negative 1.2 equals the percent change in quantity over the percent change, not percent change in price, because we know what that is, over 8%, sorry. Cooked 200 egg rolls and now my brain is also fried. All right. So I've set this up. I've got everything. Do you see that really all we're doing is solving for the numerator here? So this is a pretty easy question. How do we solve for the numerator? We cross multiply. Does everyone know what I mean by cross multiply? Right?
You multiply both sides by 8%.
Yeah, or not quite. Let's
Oh.
think of that as a form of 1. So cross multiplication means I multiply this way, and then I multiply that way, and I set them equal to each other, right? So percent change in quantity equals negative 1.2 multiplied by 8%. Now guys, can I just drop that percent sign? No, I don't have anything to cancel it with, so I can't get rid of any percent signs here. Okay, so everyone take your calculator and do not hit the percent sign. For some of you, you have a calculator that when you hit the percent sign, it multiplies it by 100. Don't do that, because you're not converting to a percent. It's already in a percent. Does that make sense?
So we just make it into a decimal.
No, just leave it like this. So in your calculator, you're going to put 1.2 multiplied by 8.
And we get 9.6.
9.6, and then you put your percent sign back on.
You get negative 9.6.
Negative 9.6. Good. Negative 9.6%. So we're going to have a percent change in quantity of negative 9.6%. So let's go back to the question. The question said, a study reports that elasticity is 1.2. Your firm's considering raising price by 8%. How will sales be impacted? What's the answer? Well, you can tell your boss that sales will fall by
A greater percent.
9.6%.
Because it's inelastic.
No, because
Are
it's
they inelastic?
It's elastic.
Remember, what did we say? Go look at the notes you just wrote down. If it's 1.2,
Oh, no,
it's
it's-
greater than 1, right?
Yeah.
And it's elastic. So let's go back, and again, remember, I tried to kind of show you that principle of greater than 1, less than 1, so you can kind of start putting all the pieces together. Let's take a look. If elasticity of demand is 1.2, then obviously it's elastic, because elasticity of demand is greater than 1. So let's remind ourselves, when we have elasticity of demand greater than 1, what do we know? Well, we know that percent change in quantity over percent change in price is greater than 1, right? We know that whole thing has to be greater than 1. If that whole thing is greater than 1, then which is bigger, the numerator or the denominator? For something mathematically, a fraction to be greater than 1, it has to be what? Which has to be bigger, the numerator or the denominator? The numerator, right? Otherwise, it would be less than 1. Everyone agree? It has to be like 5 over 3, 6 over 4, right? Does that make sense? So that tells us then that the percent change in quantity has to be greater than the percent change in price. That's just a principle of it being elastic, right? Let's make sure we agree that that happened. How much did we raise our price by?
8%.
8%. And quantity fell by how much?
9.6.
So we had a 9.6% decrease in quantity. So did the rule I just say holds? If your demand is elastic, if the demand for your product is elastic, if you change your price by 8%, quantity is going to change by more than 8%. And it did. It changed by 9.6% here, right? Remember, we don't want to violate the law of demand. If price goes up, quantity is going down. So we want to make sure that our answer always makes sense, right? So let me ask you this. If I had forgotten, what if I had, and you don't necessarily have to show this in your notes, but maybe make a note to yourself, I'm just going to show you, what if I had forgotten my negative sign, putting it back in? Well, then, do we agree, that negative sign wouldn't be there, and that negative sign wouldn't be there, and that negative sign wouldn't be there, right? So you'd end up with an answer that said quantity went what? Up by 9.6%. Now, you need to be able to look at that and go, wait a minute, that does not make sense. Why doesn't that make sense? Why doesn't that make sense?
If the customers are elastic and the price went up, why would they buy?
Okay, I think the answer is even simpler than that. How do I know, like, I've made a mistake? How do I know I've made an error here? I get the answer that percent change in quantity is positive 9.6%. What tells me I've made an error? That's not what tells me.
The elasticity of demand is not negative?
Well, that's why I made a mistake, but I want you to tell me, I get this result, I'm working Dr. Marx's test tube, I got all the numbers in the right place, that answer appears in A, B, C, D, E, and I'm like, oh, I must got it right because I find the right answer. But I actually got it wrong. How do I know I've made a mistake? When I go back and look, what tells me I've made a stupid mistake? It is not elasticity. It's something we covered before elasticity.
Law of demand.
Law of demand. Law of demand. What does law of demand tell us?
It says the lower the price, the higher the demand.
Okay, well, we're raising price in this example. So if price goes up, then
Demand should go down.
is it demand goes down? Quantity demanded. Good. Right? So the law of demand is telling me what? You've raised price. You know quantity should do what? Go down, right? So guys, if you just remember the law of demand, can you get rid of some of the wrong answers on my test? Yeah. Do you think I'm going to have some positive answers on the test? To see if you know your stuff?
Well, you're kind of mean.
I am kind of mean, aren't I? Yeah, but at least I tell you I'm going to be mean, right? So if I tell you I'm going to be mean and tricky, maybe I'm not as mean, right? So what I'm suggesting is that you have got to look at your answer. You have to go back and read the question, and you have to make sure it makes sense. And if you had forgotten your negative sign, you're going to violate the law of demand. And that should say to you, wait a minute, this doesn't make sense. Price went up and quantity's going up. I've done something wrong. I better go back and look and see if I've done something stupid. And oops, I did something stupid. I forgot my negative sign there, which means it's not there, which means it's not there, and it's not there. Do you see my point? All right. Now what if I give you a question like this? Let's say that firm ABC reduces its price.
Every time you say ABC, I think of the liquor store.
I do too. Firm ABC reduces its price from, let's say, $20 to $18 and finds that sales go up by 14%. What is elasticity demand for their product? So the ABC firm, not the alcohol firm, reduces its price from $20 to $18 and finds that sales go up by 14%. What's the elasticity of demand for their product?
Can we do this on our own?
Yeah.
Can I just test myself?
Let's do that. All right. Let's test ourselves. So write out your equation. And let's see how we do. Yeah.
I think I figured it out.
All right. Well, hold on. Let's give everyone else a chance to get the answer. All right. Everyone have an answer? Need another second? Can you take another minute? All right, everybody, what's the answer?
Negative 1.4.
1.4?
Yeah.
Somebody else got 1.4? You?
Yeah, got it.
You? 1.4? 1.4? Everyone got the same answer? Okay, I'm not sure I believe you, so let's make sure. Maybe you don't want to tell me. All right, so price goes up from goes down, from 20 to 18. So I need to use that new equation, new minus old over old. So my new price is what?
18.
18, good, minus 20 over 20 multiplied by 100%. Everyone got that part right? All right. And sales go up by 14%. So what goes on top?
14%.
14%. Okay. Can I drop anything? Can I cancel anything?
Can you drop the percent sign?
Technically, I can drop the percent signs, but I'm going to hang on to them for just a minute. So I've got 14% over, when I calculate the denominator, what do I get?
Negative 2 divided by 20.
Negative 2 divided by 20, right? Let's see, negative 2 divided by 20 is 1/10, right? Multiplied by 100%, 10%, right? Everyone have 10%? Negative 10%?
Yeah.
So I've got 14% over negative 10%. So far, so good? All right. So at this point, yes, I can cancel the percent signs, leaving me with 14 over negative 10, and that is, oh gosh, I could do that in my head. Why am I even getting my calculator?
7 over 5.
1.4, right? Negative 1.4, take the absolute value, and elasticity is 1.4. Everyone agree with that? Okay, so is demand elastic or inelastic?
It's
Elastic.
mostly elastic.
It's not mostly, it's either elastic or inelastic. So what is it?
I remember on your quiz, you asked how elastic something was. You said mostly very.
Yeah, but in this case, all we can say is really elastic. It's elastic. So on this kind of question, I'm not gonna like if it was like 1.1, I might say slightly elastic, right? It's almost unitary.
What would you say is mostly or very elastic?
I mean, there's really not a difference between, I mean, there's not a cutoff. If I saw an elasticity of 2.7, I'd be like, wow, people are pretty elastic. That's pretty price sensitive. I change price by 1% and quantity changes by 2.7, right? Almost 3 times as much. That's pretty darn elastic. So yeah. Question?
Elasticity of demand is always written as positive, right?
It's always written as positive. So on a test, when I say calculate the elasticity of demand, I'm going to have all the answers be positive. But you have to remember it was negative, and when you work backwards, you have to put the negative sign back in. But it will always be written as positive. So when economists do studies and we publish the findings of a study, we make it positive.
Okay.
But it's really negative, right? So that's just kind of one way we confuse you. So I don't know why. All right. So we agree that demand is elastic. Now, let's add on to this problem. What if I asked you, what is the impact on revenues for this company? What is the impact on revenues? So remind me, guys, what's the equation for revenue?
Price times quantity.
Good. Price times quantity. Okay? So let's do one together, and then we're going to do another problem that you work all by yourself. How much did price change by? What did we say? Price did what? Did it go up or down?
10%.
Price go up or down?
You went down.
Down by how much?
$2. So
Percentage-wise, sorry.
10%.
Okay? Price went down by 10%, right? Everyone agree with that? I gave that to you, or we calculated it right here. Everyone agree? In the denominator. And that's why I didn't drop the percentage signs. If you leave them in, then you can answer the next question about total revenue, right? Does that make sense? How much did quantity change?
It went up.
It went up by how much?
14%.
14%. Good. All right. So I've kind of sketched out a little diagram here. I've lowered price. Did people react, guys? Did they go, I don't really care about this project? Or did they go, oh, price is lower, I'm going to buy a little more?
Buy more.
Yeah, they're buying more, and they're buying more, enough more to offset the price losing money, right? So take a look. Does everyone agree we're losing some revenues when we lower price, right?
Mm-hmm.
We're losing revenue when we lower price. But we gain revenue when people buy more, right? And so really all we have to do is figure out which is bigger. So we agree, we lose revenue from this. When we lower the price, we lose revenue. And we gain revenue from this. So all I really have to do is figure out, is the gain or is the loss larger, which is the dominant effect. So in this case,
Clearly.
what do we see?
Revenue increase.
Yeah, revenue on net is going to increase, right? So revenue will increase. So let's remind ourselves. Is everyone with me? Everyone see that last part? That makes sense to everyone? You can figure out impact on revenue? But do you see how it's easier if you leave the percentage signs in here and cancel them a little bit later? Then you have what you need to plug into this little diagram for revenue, right? So let's look at what we've just said. We've said that the firm increases price, and as a result, their revenue, they lower price, my bad. They lower price, they lower price, and as a result, their revenue goes up. All right, everyone agree? That's the answer we just got. We lower our price, but our revenues went up. So let's think about what we can infer here, right? This is enough for you to know what the elasticity is. Even if I didn't know the answer, I can figure out the answer here, right? Because either people walk in and they see a sale and they're like, or they walk in and see a sale and they go, ooh, a sale. Which kind of customer do you want? When you put your stuff on sale, do you want people to go, or do you want them to go, ooh, a sale, right? You want them to go, ooh, a sale.
You want the customer that's willing to spend money for the sake of spending money.
Hold on, that doesn't make any sense. We've lowered price. I'm simply asking, when we lower price, we want people who respond to the incentive you've given them to buy, right? So, what does that tell you about the kind of consumer we have? They walk in, they see a sale, and they react.
They're super elastic.
They are
Price sensitive.
They're price sensitive. So we know our consumers are price sensitive. And then what did we say we call consumers that are price sensitive? They are what kind of elasticity? Elastic. Right? I mean, they're not outrageously elastic, but they're elastic. You with me? So can I give you a question just like that? And you can tell me about elasticity? Sure. You got to be able to think backwards like that, okay? So let's do some more. All right. So let's say Longwood University. Wants to increase its price by 19%.
God forbid.
I know. And studies, oops, I should say studies. And studies reveal that the elasticity demand of its consumers is 1.8.
Ooh.
So we can from here say what will happen to enrollment and what will happen to revenues. So everybody work that question. Remember, start with the equation. So everyone take a minute and work through that. Then we're going to check it. Everyone know how to get started? Anyone need help?
Correct and minus say all you have to do is multiply.
right, so take another 30 seconds and finish, and then we'll go through it together. All right, let's work the first part together, and then I'll give you a second if you need for the second part. All right, so we need to plug in what we know. What do we need to plug in for elasticity of demand? Negative 1.8, right? We have to undo the absolute value that we took because we know P and Q move in the opposite direction, okay? What else can we plug in?
Price.
Yeah, they want to increase price by 19%. Good Lord, that would be a lot, right? So let's hope that doesn't come to fruition. So we've got negative 1.8 equals, we're going to solve for percent change in quantity. And we know price goes up by 19%, right? Everyone remember how to cross multiply here. That's not something you remember. Well, in case you don't want to admit it, remember it's kind of like having a 1 under here, right? So we're going to multiply in this direction, and we're going to multiply in that direction and set them equal. So we've got negative 1.8 multiplied by 19%, don't drop the percentage sign, equals percent change in quantity, right? Everyone have that? So that gives me a percentage change in quantity that's equal to
Negative 34.
negative 34, is that right? 1.8 equals, yeah, 34.2. Does everyone have a negative 34.2%? So what are we going to advise the university? Hey, your consumers are pretty what? 1.8 is what? Elastic or inelastic?
Elastic.
They're pretty elastic, right? That's pretty darn price sensitive, right? Think about what it means. Every 1% you change price, they're going to respond by cutting back by 1.8%. That's pretty price responsive, right? And you want to increase your price by 19%. What's the outcome? You're going to decrease your enrollment by 34.2%. Is this a good idea?
No.
Is this a good idea? Probably not, but let's prove it to ourselves by looking at the impact on revenue.
The losses are greater than the gains.
Well, let's let everyone have a chance to figure it out. All right. So guys, impact on revenue. Revenue equals P times Q, right? So, drawing your arrows is the easiest way. Price changed by what?
Increased by 19.
Increased by 19%. All right. So does everyone agree that revenues will go up from the price effect, but I also have to remember what? Quantity goes down by what? Really big, right? 34.2%. And so revenues will go down from the quantity effect. So when I combine them, when I look at the dominant effect, what's the impact on revenues, everyone?
Everything goes to
Revenues will go down. And not just a little bit, right? They're going to go down a lot,
close to twice.
right? A lot. So would you advise the university to impose this? No. But what if instead, everyone have this down? What if instead the university had a slightly different elasticity, or a very different elasticity? What if elasticity demand for attendance at Longwood was actually 0.9 instead of 1.8?
So half.
And again, the university wants to increase price by 19%. So let's look at the effect on enrollment. And let's look at the impact on revenues. Okay, so we're doing the same question, but instead we're changing elasticity to be 0.9. Why do you think I chose 0.9?
It's an inelastic.
Ah, we've made it less than 1, which is inelastic. Good.
It's probably
So-
a more realistic
okay.
number too.
So, everyone calculate this. Everyone have an answer? All right, so I need to plug in what we know. What can I plug in for elasticity?
-0.9.
-0.9. And what can I plug in for price?
19%.
Positive 19%, right? So, right? Everyone agree? Okay. So, -0.9 equals, we're going to solve for percent change in quantity over 19%, right? Everyone remember how to cross multiply? Okay, we're going to take -0.9 multiplied by 19% equals our percent change in quantity. So, 19 times 0.9, 17, thank you, negative 17%. So, enrollment's going to fall by 17%.
I have a question. So
Uh-huh.
on the test, would you normally want us to just round that 0.1? Just make it, just write it down like 17? Because when I did it, I got negative.
Oh, it's 70.1. I'm sorry. I have a shadow on my calculator. I know I'll probably put 17.1.
As a
So,
multiple choice
sorry about
answer.
that. Yeah, well, it depends. But yeah, I would always say carry through a decimal when you're working through the problem, carry at least one decimal, round at the end. It'll be multiple choice for this portion of the test, so you'll be able to find your answer, but if you round too much, your answer might be a little too different. It might confuse you when you don't see your exact answer.
Okay.
So carry some decimals. So enrollment falls by 17.1%. All right. So, how would you advise the university? What's going to happen to revenues?
So the price would go up by 19.
Okay, so we've got price times quantity. We've got, let me change colors, price going up by 19%.
Falling.
Okay, and quantities falling by, oops, sorry, that is not right. They're falling by what?
17.
They're falling by 17%. So what happens to revenues here, guys?
Goes down.
Decreases.
Does revenue go down or does it go up? So revenues goes up from this, and revenues go down from this, right? Which effect is bigger? The increase or the decrease? This is 19%, this is 17%. So if something goes up by 19% and something falls by 17%, what's the net effect?
2%
That which direction? Up or down?
down.
Well, which is bigger? The up or the down? The up. The up is bigger than the down. So in net, what's the effect? Revenues do what?
Decrease.
They go up, right? Does that make sense? That doesn't make sense?
Because before you said revenue went down because quantity demand was bigger.
But remember, I made a very big change. I changed our elasticity to 0.9, right?
Never mind.
Right? So that's my point. You're making my point. In the previous example, let's go back to that. In the previous example, did I get there? Yes. In the previous example, we changed our price by 19% and revenues went down.
That's good.
But here, what happens to revenues?
We changed it and it went up.
Yeah, revenues actually go up. Now, do they go up a lot?
No.
They don't go up a lot, but revenues went up. So what's the difference? Why in the previous example did our revenues go down, and then this example with the same exact 19% change in price, revenues go up here? What's the difference, everyone?
The elasticity of demand.
The price responsiveness of consumers, right? Over here in the first example, consumers are elastic. How do elastic consumers behave? I'm not going to Longwood University. I'm going to go somewhere else. You're raising your price 19%. I'm going to go apply to some other school, right?
I'm going to Hampton, Sydney.
We're not going to Hampton City. We're going to Radford. We're going to JMU. We're going to Tech, right? I mean, Hampton Sydney, if you're worried about 19% increase of tuition here, you're not at Hampton Sydney at 53.
Might as well get my
But
master's.
when I change my elasticity to 0.9, our consumers are what? Inelastic. And inelastic consumers say, I've always wanted to go to Longwood. My parents went to Longwood. The campus is so beautiful. I heard they have this like rockin' econ professor. She's really hard and makes me do a lot of homework. But, I hear their econ program is just awesome. I'm going to Longwood, right? Price responsivity matters. Remember I gave you the example of my husband, a CPA, and people are really loyal to him. People don't change accountants very often. He can raise his price, not a lot, but he can change it a little. He'll lose a couple clients, but everyone else is paying more. He makes more money, right? But if he raises his price and people say, I'm not paying Kevin Sheehan to do my taxes, I'm going to go find somebody else. Now he's kind of cut off his nose to spite his face. It's backfired on him. His sales have fallen too much and his revenues actually go down. Does that make sense? So before we start messing with our price, what do we need to know? Are our consumers elastic or inelastic?
And
All right.
how much?
And just how much. But most specifically, I need to know elastic or inelastic. So let's say that we lower the price of our product and find that our revenues fall. From this, we know our consumers are, don't answer it yet, take a second and read it. We lower the price of our product. We find that our revenues fall. From this, we know our consumers are blank. Everyone fill in the blank. Don't answer out loud, just fill in the blank. Everyone have an answer? What's the answer?
Elastic.
They are
Ah,
inelastic. Everyone got that right? So you have a couple ways you can figure this out. First of all, you lower the price of your product. You put it on sale. You want people to walk in and go, ooh, a sale, and buy more. And when people walk in and go, ooh, a sale, and they buy more, you make more money. But that didn't happen. So that tells you people walked in and did what? Ooh,
Ignored
a
the
sale. I don't really care about this product. I don't really feel like buying any more of it.
a quarter
So
of a
it
can.
backfired on you, right? You just had a sale and people did not respond. And people who don't respond to price changes are what? More inelastic. They're inelastic, right? Our consumers are inelastic. Everyone agree with that? Now, if you find yourself getting confused on a test, let's look at how we can sketch this out. Revenue equals P times Q. Now, let's plug in what we know. We lowered the price of our product, but our revenues fell.
Which means you didn't make any money.
What was that?
Which means you didn't make any money. So
Okay.
it would be inelastic.
Right, but what do I draw here to kind of sketch it out for myself? I lowered my price,
And quantity goes down.
and, well, if I lower my price, quantity doesn't go down. That violates the law of demand. It goes up, but does it go up a lot?
No.
Or does it go up a little? Yeah. The problem is I lowered my price. Let's say, I'm just going to make up a number, 10%. And I got more sales, but maybe it was only 5%. In other words, people didn't jump on this sale. I was hoping people would buy 15% more, but they didn't. So, I can get that far. Everyone can get that far, right? That makes sense. So, what do we know here? The percent change in price had to have been greater than the percent change in quantity. Right? I know that. And this is the denominator of my elasticity equation. And it's greater than my numerator. So if I have an equation where my denominator is greater, what does that tell me? It has to be what? Greater or less than 1? If I have an equation where the denominator is greater than the numerator, that would be like 3 over 5, or 2 over 3, or 1 over 2.
You get less than 1.
Then I know
It's inhomogeneous.
elasticity of demand has to be less than 1, right? And that is what we call inelastic. Everyone agree? Easy, right? All right, one more. We increase our price from $4 to $5, and as a result, sales fall from 100 to 75. It says 100. 100 to 75. Can't read that very well. What is the elasticity of demand? What is the impact on revenues? So everyone work it. take another minute and finish it. We'll go through it. Everyone have an elasticity of demand calculated? All right, everyone, what did we get for elasticity of demand?
1.25.
What'd you get?
1.25.
1.25?
Yeah.
Yeah, I don't think it's 1.25. I think that percent change in price was 25%, and percent change in quantity was negative 25%. Everyone get that? Okay, so that gives me a -1, right? Everyone agree? Which gives me a elasticity of demand of 1. Everyone agree? So what do we call elasticity of demand equal to 1? Is it inelastic? Is it elastic? What do we call it? Unitary elastic. Good. Unitary elastic. So, what happens to revenues here?
So the price of revenue went up. Right?
Revenue goes up. Did you guys get revenue going up?
What if the
Revenue
revenue
stays the
went
same.
down?
Revenue went down. Well, let's plug it into the equation.
Professor,
Hold on. Price times quantity. Now everyone take a second and draw your arrows in the right direction. So, price went up and sales went down, right? But you got to draw them both being what? 25%, right? So, price went up by 25%. Everyone agree? And quantity fell by 25%, the exact same magnitude, right? So we know that this will increase revenue and the other effect will decrease revenue. But what's the net effect?
It went down.
Does it go down?
It's the same.
What did you just say?
It's the same.
Stays the same, exactly. Revenues don't change here
Because they're constant.
because one effect decreases it and the other effect increases it by the exact same amount, right? So is this price increase going to make the firm more money in revenue? No, because at this particular point, their consumers have unitary elastic demand. All right, everybody with me? You feel a little more comfortable with elasticity demand? All right, so my suggestion is, now that you have a better sense of it, we've essentially done every type of question that you've seen in homework and quiz, okay, on the calculations. And I specifically didn't do the identical questions so that you could go back and practice. Now you should be able to go through them and get the right answer, and I would urge you to do that and make sure that you can work them all and get them right. All right? Okay, well, thanks for coming, guys.